Hello everyone, I am Sunanda from SNS College of Technology. Now, as the continuation of the lecture series, let us see Euler-Cauchy homogeneous linear equations. This Euler-Cauchy and Legendre differential equation comes under higher order differential equations with variable coefficients. So far we have problems including constant coefficients. Here we are going to see Euler-Cauchy in which we have constants as variables, that is in terms of x. So here in this we are going to replace x by e power z and log x by z and xd as d dash or theta dash, and we are going to replace x square d square by d dash square minus d dash. Now let us see the problem on Cauchy. Solved by Cauchy method. Here we are going to have an equation as x square y double dash plus 2xy dash equal to 0. So in the place of y dash we can replace it by d square into y. So therefore we will have the equation as x square d square plus 2xd into y equal to 0. Mark this as an equation number 1. Next is we are going to apply the substitutions. In the place of x square d square we are going to substitute d dash square minus d dash, and in the place of xd we are going to replace it by d dash. On replacing these in equation number 1, we will have d dash square minus d dash plus 2d dash into y equal to 0. On simplification we will have d dash square plus d dash into y equal to 0. Now let us write the auxiliary equation for this equation, which is m square plus m equal to 0. Now the roots of this equation will be m equal to 0 and m equal to minus 1. So the CF for this will be a e power 0x plus b e power minus z, since the equation is substituted in terms of z. Next is our CF will be a plus b e power minus z. Since phi of x is 0 here, our y is equal to CF, which is a plus b by x. Now let us see one more problem on this. Consider the equation x square d square minus 3xd plus 4 into y equal to x square. So now we are going to substitute the substitutions as we have seen already in the previous problem. On substitution we will have d dash square minus d dash minus 3d dash plus 4 into y equal to x square. On simplification we will have d dash square minus 4d dash plus 4 into y equal to e power 2z. Now we have to write the auxiliary equation for this problem, which is m square minus 4m plus 4 equal to 0. The roots of these equations is m equal to 2 comma 2. So since the roots are real and same, we are going to write it as a plus b z into e power 2z, since we have substituted in terms of z. Now let us find the particular integral for this, which is 1 by d dash square minus 4d dash plus 4 into e power 2z. Here the coefficient of z is 2, therefore we are going to substitute d dash as 2. 1 by 2 square minus 4 into 2 plus 4 into e power 2z. Here the denominator is becoming 0, which is a failure case. So we are going to multiply the numerator by z and differentiate the denominator. So therefore we will have z divided by 2d dash minus 4 into e power 2z. On simplification again we get 0. Therefore we are going to again repeat the same iteration, and we have the particular integral to be z square divided by 2 into e power 2z. We are going to replace z in terms of x. Therefore we have our particular integral to be log x the whole square divided by 2 into x square. Our y equal to cf plus pi. Substitute our cf and pi, which is a plus b log x into x square plus log x the whole square divided by 2 into x square. In the next video, let us see problems on Legendre linear differential equations. Thank you.